Now let's go over section 10.2. This is on area of trapezoids, rhombuses, and kites. So yesterday we went over area of a parallelogram, rectangle, and triangle. And so now we're just doing more area formulas. So in this case, area of a trapezoid is 1/2 times the height. And then in parentheses, we're going to put base 1 plus base 2. Okay, again, if we look at a picture of a trapezoid here, one of the properties we talked about, and again, we talked a lot about trapezoids and all of these different shapes in chapter 6, and so now we're just dealing with the areas of these. So one thing we talked about is that there's one set of parallel bases for a trapezoid. The other two legs are not parallel to each other, and again, the height forms a right angle with one of the bases. It's the right angle distance between the two bases. So, you know, sometimes the trapezoids turn differently on its side or something, so be looking for what are the two parallel sides, those are the two bases, and that height is the right angle distance between those two bases. All right, so if we look at this first one, it says, what is the approximate area of Nevada? And you can see that Nevada is a trapezoid. Here's our two parallel sides that we can consider to be our bases, so we'll go ahead and call this base 1 and this base 2. It really doesn't matter which you label base 1 and which you label base 2. And then I can see this is my right angle distance between the two bases, and so that would then be my height, which is 309 miles. So I like to always write the formula first that I'm using. So area is equal to 1/2 times height times base 1 plus base 2. And now I can work on plugging in what I know and again solving for the thing I don't know. In this case, I can see that my height is 309. And I can see my two bases are 205 and 511. Okay, so I like to go ahead and split this up a little bit. I like to go ahead and add what's in the parentheses first. And then I'll worry about multiplying everything. So if I add up 205 plus 511, I get 716. And now if I go ahead and put this in my calculator, similar to what we talked about with the triangle yesterday, is I can either do 0.5 times 309 times 716, or I can do 309 times 716 equals and then divide by 2. But either way, in this case, I would get 110,000, 622 miles squared. Again, don't forget to put units with your answer. Again, a big number, but state of Nevada is pretty big. All right, next we can look at example 2. And on example 2, it's asking us to find the area of the right trapezoid PQRS. So we can see over here that, again, first I like to usually write down the formula, 1/2 height times base 1 plus base 2. Okay, they're asking me for the area, so, you know, I should have a number to plug into all of these. If I look at this, I can see here's my two parallel sides, so I'm going to call this base 1, I'm going to call this 7 base 2. And then I know my height has to form a right angle with the base. I can see a right angle here, so I know this is the height. Okay, but I don't know what that length is. I do have a clue here that this is 60. Okay, so maybe if I draw the height over here, it will give me an idea. Because if that's the height, that also represents the height. And then that does give me an idea, seeing that 60 there. Okay, I know if it's 5 from here to here, then that means, you know, it's also 5 from here to here. And if I know that it's, 7 from here to here, then I can see that right here has to be a length of 2. Okay, and I can see that's a 30, 60, 90 triangle, so like we talked about in chapter 8, it is going to be really important to learn that information in chapter 8 because we're going to use it in chapter 10 and chapter 11, the 30, 60, 90, 45, 45, 90, and sine, cosine, and tangent. So if you need to look back at some of that chapter 8 stuff, refresh your memory, you can, and I'll kind of remind you of some of these things as we go through here. So I can see that across from the 30, this 2 is my short leg, and I'm trying to find the long leg that's across from the 60. And if you remember, the relationship between the short leg and a long leg of 30, 60, 90 is square root of 3. So if I know the short leg is 2, and I'm trying to get the long leg, I know I'm trying to get a bigger number because the long leg is longer than the short leg. So therefore, I'm going to multiply by square root of 3. So 2 times square root of 3 is 2 square root of 3. Okay? And so that is my height, and now I have enough information to plug in. So I've got 1/2, my height is 2 square root of 3, and my bases are 5 and 7. Okay? So again, I like to go and add what's in here first, which is 12. And now, if it didn't specify how to leave my answer, I'm going to leave it both ways for this time. First, we'll leave it in exact form. So that means I'd multiply everything except for the square root. If I do, 0.5 times 2 times 12, then I get 6 square root of 3. Or if I go ahead and multiply 6 times square root of 3, if they do ask it in decimal form, then I would get 20.8. So just make sure you know how to do both ways so that you will be prepared to answer it either way that you are asked. And that is going to be meters squared. Okay? And then on example 3, it says find the area of the right trapezoid. So again, this one's very similar. I'll go ahead and write my formula down first. 1/2 times height times base 1 plus base 2. And if I go ahead and look at that, I can see that I know what one of the bases is, okay, but I don't know this other base yet. I have to figure that out. I also don't know what the height is. They did give me that 12, but that's kind of a slanted line. Remember, the height forms a right angle with the base. That's the height. If I want to draw the height over here, I can. That also represents the height. Okay, and I need to figure that out. So if this length is 60, and let me go ahead and bracket this whole thing as being 14. If this length is 60, this is 90. I know that's 30. So again, this time I know the 12 that's across the right angle, that is my hypotenuse. And I want to figure out what this length is from here to here. Okay, which is the short leg. I also want to figure out what this length is from here to here, which is the long leg. But I need to go from hypotenuse to short leg first. So if I know the hypotenuse is 12 and I'm trying to find the short leg, remember the hypotenuse is always going to be the biggest length of a triangle, right triangle. So if I'm trying to get the short leg, I'm trying to find a smaller number, so that tells me I'm going to divide. Remember that magic number is 2, so I'm going to divide by 2. So 12 divided by 2 gives me 6. And then once I know the short leg, I can find the long leg. Remember, I'm trying to get a bigger number, so I multiply. And what I multiply by is square root of 3. So 6 times square root of 3 is 6 square root of 3. Okay, I still don't have the base down here yet. So if I knew from here to here was 6, and I knew here to here is 14, all the way across here to 14, then I know I can go 14 minus 6 to get 8. From here to here, which therefore this is 8. Okay, again, pictures are not always drawn to scale. Obviously, that's telling me that's 6 and that's 8. But again, you've got to go with the numbers given in the problem. It's not always drawn to scale. They don't want you guessing what the answers are. So I can plug in what I know into my formula. And I just found my height was 6 square root of 3. And I found my bases. One base is 14 all the way across the top. And my other base was 8. And when I get that plugged in, I like to go and add the 14 and the 8 first. And that gives me 22. Again, I didn't specify how to leave my answer, so I'm going to leave it in exact form and decimal form. So exact form, I could go 0.5 times 6 times 22, which would give me 66 square root of 3. If I go ahead and multiply 66 times square root of 3, in case I do want it in decimal form, round it to the nearest tenth would be 114.3, and that would be centimeters squared. All right, so let's go ahead and go to the next page. So on the next page, we are going to talk about the area of a kite and a rhombus. So let me get that moved up. All right. So the area for both of these is 1/2 times diagonal 1 times diagonal 2. All right, a key thing about that is the diagonals are perpendicular bisectors of each other. And this is for a rhombus, so go ahead and specify that here, is that diagonals are perpendicular bisectors of each other. So here's a picture of a rhombus, and we can tell that if the diagonals are perpendicular bisectors of each other, then that means that, again, where the diagonals meet up, we talked about this in chapter 6, that these are all going to be right angles here. And the other thing that we talked about, we do know for a rhombus all the sides are congruent to each other, but a couple other key things, if the diagonals are perpendicular bisectors of each other, that means this one cuts this one in half, which means these little pieces are congruent. And it also means that this one cuts this one in half, which means these little pieces are congruent. So that can kind of help you figure out some information in terms of solving for area. All right, for the kite, a key thing over here is that the shorter diagonal, okay, and let's specify this as working for a kite. The shorter diagonal is bisected by the longer diagonal, and the diagonals are also perpendicular. So again, we know the diagonals are perpendicular, so I can put my right angle symbols in here. And it says the shorter one is bisected by the longer one. So if the longer one cuts the shorter one in half, then I already have 1 mark here, 2 mark here. So I'm going to go 3 mark there. Okay. And again, one thing about a kite is that these 2 longer sides are always congruent, and then these 2 shorter sides are congruent to each other. All right, so that's kind of key information you need for a kite and a rhombus, and now we're going to actually practice solving these, but let me get this moved up first. So, okay, on number 4, it says find the area of the kite or the rhombus. So again, I like to start with the formula, and we just talked about the formula is 1/2 diagonal 1 times diagonal 2. And again, it's that whole diagonal all the way across. If they're just showing me that this is 3, the arrow's pointing here, that's talking about just from here to here. So if that piece is 3, then I know that piece is also 3. So I know therefore that that whole diagonal is 3 plus 3, which is 6. I'm going to get that plugged in. Okay. On the other side, I can see that they're showing me that this is 5 from here to here. I'm going to put 3 marks on that. So therefore, I know that over here, this piece is also 5. And so therefore, I know this whole diagonal is 5 plus 5, which is 10. Okay, and now I can just get it worked out from there. And I can see that is going to be 30. And it's in feet, so that's going to be feet squared. The area of that kite. Okay. Actually, for that rhombus, that one is a rhombus. So down here, now we're dealing with a kite, and again, same formula. We've got areas equal to 1/2 diagonal 1 times diagonal 2. We're not adding those together. Sometimes after just doing the trapezoid ones where you're adding the bases, people accidentally add these. You're adding the pieces to get the whole diagonal, adding the pieces to get the whole diagonal, but then when you're actually using the formula, you're multiplying here. So in this case, if we look at what's given, I can see that this piece is 10, and I can see this piece is 10, so therefore this whole diagonal is 20. So when I go to plug that in, I want to be careful to put 20 in there and not 10. Okay? If I look over here, I can see this piece is 10, and I can see that this piece is 20, so if I add those up, I can see 10 plus 20 is 30. And then if I get that plugged in my calculator, I can see that I get 300, and my units would be meters squared. Make sure you're putting units with your answer. Okay? And then the last couple on number 6 and 7. Thought I had to move it up at my computer, but I forgot I adjusted it so we can go here. So on number 6 and 7, we got a rhombus and a kite again. And in this case, they've given me a little extra information. They're showing me this whole diagonal is 10. Okay, they're showing me one side of the rhombus is 8, And then they're giving me a hint here to draw the other diagonal to make right angles at the intersection, then use the Pythagorean theorem to find the other diagonal. They might not always give you that hint, but they're being nice now to give you that hint. So again, the formula I'm going to use is 1/2 diagonal 1 times diagonal 2. Okay? But before I do that, I'm going to use this hint here. I know that if I go and draw this, then, okay, I know my diagonals are perpendicular, so I'm going to get my right angles in here. I know that if this whole thing was 10, then I've got 5 and 5 here now. Okay? And I also need to figure out what this whole diagonal is, but I can start off with just finding out what this piece is. Okay, and again, I can use Pythagorean theorem to figure that out, knowing that that is 8. So if I do that off to the side here, I'm just looking at this right triangle right here, and I know across the right angle is 8, so that's my hypotenuse. And for A and B are my X and my 5. And if I get that worked out, 5 squared is 25, 8 squared is 64. If I go and subtract 25 from both sides, then I get 39. And if I go and take the square root of both sides, I just have square root of 39. Okay, so that gives me this length. And I also know that this length is also square root of 39. So I'm going to put that in my picture. Let's see. So that's square root of 39, and that's square root of 39. So now if I plug my information into my formula, I know that one diagonal they gave me to begin with was 10, so that's the easy part. My other diagonal is square root of 39 plus square root of 39, which is actually, I don't want to do a decimal at this point yet. I don't want to round and round throughout the problem, so I'm just going to write it as 2 square root of 39. And then now if I go and get that plugged in my calculator, again, I'm going to leave it in exact form first. So 0.5 times 10 times 2 equals 10 square root of 39. So that would be my answer in exact form. If I want it in decimal form, rounded to the nearest tenth, and I plug that in, I'd have 62.4 inches squared. Okay. All right, and then on number 7, we can see here my diagonals are perpendicular to each other. All right, and again, this one is a kite. So I've got my formula, 1/2 diagonal 1 times diagonal 2. And in this case, I can see that one of the diagonals is 4 plus 11, which is 15. And for the other one, I just have to remember one of the things we talked about at the top of the page here is that the longer diagonal bisects the shorter one. And so if this is 6, then this is also 6 over here. So that whole length is 12. So just be careful that you're not plugging 6 in there. You need to add 6 plus 6 to give you a 12. And then when you go and get that plugged in your calculator, you get 90. In this case, your units are going to be meters squared. All right, so that is it for section 10.2. So again, feel free to message me on Canvas if you have any questions. Feel free to go back and pause, or slow it down if you need to see some of that again. And I'll see you next time.